Hello, in this lesson, we are going to discuss about the increasing and decreasing functions to prepare for the graphing of functions. So increasing and decreasing, it means from left to right, the x positive direction, we walk from left to right, we are going to see the graph is go up or go down. So for this one, from left to right, here the slope is negative, so it's decreasing. DEC represent decreasing. And from here to here, you will see the from left to right, the graph is going up. So this part, the slope is positive, is increasing. From here to here, you will see from left to right, the graph is going down. So the slope of this part is negative, so it's decreasing. From here to here is from left to right is going up. The slope is positive, so it's increasing. So from this, you will see what we are discussing about is a slope. The slope for a function is a derivative of a function. So what we are going to see is the f prime is positive, then greater than 0, we know is increasing. And if f prime is negative, then from left to right it's going down, so it's decreasing. So this is what we are going to discuss about. And also we have several important points is a slope at this point, the tangent equals 0. This is what we have discussed in our last chapter. They are the local minimum maximum point. So slope is 0. It may be local maximum, maybe local minimum. So these are the first derivative, and here we call it endpoint, and here we call it is a local minimum from left to right. The f prime is changing from negative to positive, so it's a local minimum. So negative to positive, the sign changed, and here from positive to negative for the derivative, then we have a local maximum. The sign of the first derivative changed, and from here is negative to positive, so we have a local minimum. So these are the key information you should know. For the concave up or concave down, we are going to learn this one in 4.3 or 4 again. So concave up is kind of you put your hand, hold your hands here, your palm will be up. You hold your hands here, your palm will be down, so concave down. You form your hand palm this way, then it's palm up. So this is your palm open. You put your hands there. The palm opening is up or down. This is a concave up or concave down. So this, you put your palm here. It will naturally open up, then it's concave up. So in this lesson, what you have to know is determine the increasing, decreasing intervals. And how to determine increasing, decreasing, just find derivative greater than 0 or equal to less than 0. Okay, so let's see the first example. So example 1. Use a derivative to determine the value of x for which the function values, the y value is increasing or decreasing. So find the intervals for increasing or decreasing. So in order to find the increasing, decreasing, we know we need to find the first derivative. So we are going to apply the derivative to a polynomials for this lesson. In future, you are going to find the derivative for the rational functions, etc. So this one, the first derivative, it will be dy over dx. Or you could just write it as y prime. Then x cubed bring the two options, 3 degree to the front, then degree minus 1. So 1 multiplication, 1 minus, plus 3, then bring the 2 to the front, then degree minus 1. The constant, 2 minus 1 is 1. Constant x to the exponent 0, bring 0 to the front, will be 0, so no constant term, is just 0. So 3x squared plus 6x. Now we want to find the derivative positive, negative. Before that, we want to find the zeros first. Then from the zeros, we want to draw a chart and see where it will be positive, where it will be negative. So we want to find the first derivative equals 0. Then from there, we want to find where positive, where negative by drawing a chart. So 3x squared plus 6x equals 0. So you have two terms. We have the common factors from these two terms. So we want to do just the common factoring. So 3 and 6, we have common factor 3. X squared x, we have common factor is the lowest degree. So 2 and 1 lowest degree is 1. So we have x to the exponent 1 as a common factor for variables. So 3x squared divided by 3x, we have x. 6x divided by 3x, we have 2. Then we have it factored. Two factors times together equals 0. Then either of them may be 0. So we have 3x equals 0 or x plus 2 equals 0. So each of them is a linear equation. In order to solve linear equation, it just isolate the x. So we move the 3 to other side, it will be divided 3 to both sides. So opposite operation, so x equals 0. And for the second one is isolate x, move the plus 2 to other side, opposite operation is minus 2. So x equals negative 2. So we have these two x equals 0s. Now we are going to draw a chart, kind of like a chart. So method 1, we want to draw a chart. So we want to put, this is our kind of like the x-axis. So we put negative 2 here. This is our zeros. And we put 0 here. This is our zeros. Then for the column, we want to find is y prime is positive or negative. So y prime, we have two factors. We put the two factors here. So 3x times x plus 2 will give you the y prime. And we want to find that on the left and the right of the y prime equals 0, what those factor positive or negative. So we are going to pick a random number. So this one is just on the left side of negative 2 is x less than negative 2. We pick one value, negative 3 here. So negative 3 put here, 3 times negative 3 give you negative, negative 3 plus 2 give you negative. Then we know the final y prime is times together give you positive. So this, by doing this way, we divided the x-axis into 3 intervals, less than negative 2, between the negative 2 and 0, and also x greater than 0. So 3 intervals, and we decide each interval the factors positive or negative, then determine the y prime is positive or negative. So the next one, we just pick a number, negative 1, sub in. 3 times negative 1 is negative. Negative 1 plus 2 give you positive. Times together give you negative. So y prime is negative, here is decreasing. So positive means increasing the slope. X positive greater than 0, we pick a number, just positive 1 here. Sub in 3 times positive 1 give you positive 3. 1 plus 2 give you positive, so times together is positive, it's increasing. So by drawing this chart, you will see you can easily to tell where the function is increasing, where is decreasing. So this is a chart method, and how to draw this chart. Put the zeros on the x-axis and divided the x-axis into several intervals. So from this chart, we are going to see that increasing is x less than -2 and also x greater than 0. So this is how. And the decreasing is y prime is negative, is from -2 to +0, minimum, maximum, then less than, less than. So how to write the interval? We want to write it in this way. We want to write minimum, maximum, then less than x. So this is how to find the intervals. This is by drawing the chart. Then second method. Method 2, we want to just graphing the f prime, the y prime right away, okay? So we have x-axis, we have two zeros. One is x equals 0, another one is x equals -2. And the same thing, we want to draw this 3x times x plus 2. Then we want to sub in a number, so 3x, we sub in a number -3. You will see -9 times -1 is positive. So this part, the y prime, is positive. And here we pick a number -1, sub in, you will find out -1, 3 times -1 plus 2 give you negative, so it's less than 0. And greater than 0, the y prime is positive again. So this is our y prime. And from our y prime, you will see when the y prime is positive. So when the y prime is positive, the graph of the function f, the y function is increasing for these two intervals, shaded intervals. So x less than -2 and x greater than 0 will give you this increasing y prime is 0. And from y is decreasing when the y prime is negative. So it's from -2 to +0, minimum, maximum, x in between, less than, less than. So this is the two ways you can do it. So one is just graph the y prime and find out positive or negative. Another way is just draw the chart. I prefer to use a chart because in future, when we do the graphing of functions, we want to use this chart. We are going to graph not only y prime, but also the y value and the y prime prime, double prime to do the graph of a function. So now we are going to do the second one. The second one is a rational function. So we want to find the y prime again. And for this one, there are two ways. One way is change it to the multiplication, or another way is just do the derivative of a quotient. So it will be denominator squared. Then first come first derivative. So denominator squared, then first come first derivative minus second derivative u times v. So x derivative is 1, then copy the new denominator here, then minus x times denominator derivative is 2x. Then we simplify it. X squared plus 1 minus 2x squared divided by x squared plus 1 bracket squared. So simplify, you will have negative x squared. X squared, same variable, same degree, they are like terms. When we add, subtract like terms, we just add the number at front. So no numbers means 1. 1 minus 2, negative 1. We don't write 1 here. 1 times x squared is just x squared plus 1 over x squared plus 1 bracket squared. Then we want to solve for y prime equals 0. So negative x squared plus 1 all over x squared plus 1 bracket squared equals 0. We don't want to see the denominator, we times it to other side. 0 times anything give you 0, so we only have negative x squared plus 1. Then we could move the negative x squared to other side. Square rooted both sides. Always remember when you square root something, you have positive and negative. And now we want to do the chart again. So we are going to do the chart. So how to draw the chart? This is x-axis. We put the 2 zeros here. So negative 1 and positive 1. On the left side is x less than negative 1. In between is minimum, maximum. X in between less than. Then this part is x greater than 1. So we want to find the y prime is positive or negative. So we just copy negative x squared plus 1 is our numerator. Denominator is x squared plus 1 bracket squared. Then these two divide give you y prime. So when x less than negative 2, negative 1, we just pick a random number, negative 2 or negative 100. We put here, you will see negative 2 squared give you negative 4 plus 1 is negative. This one is doesn't matter what number, then squared always positive. So negative divided by positive give you negative. So here we pick number 0. Negative 0 squared is gone. So only have positive 1 is positive. Positive divided by positive give you positive. X greater than 1, we pick 2. 2 sub in negative 2 squared give you negative 4. Plus 1 is negative. So divide is negative. If negative, it means the slope is negative. It's from left to right, is down. It's decreasing. This one positive means from left to right is up. The slope is positive, so the graph is increasing. So we write the statement, therefore, y is increasing. The interval will be just from negative 1 to positive 1. Put x in between less than. Then the decreasing will be the other two. This part, x and less than negative 1 or x greater than 1. So the opening is facing the larger number. So this is what we want you to know for today. So you need to know how to find the increasing, decreasing intervals. And in grade 12 advanced functions, you may have learned that for this one cubed, it will be this direction. So it's positive, then it will be from the first third quadrant to the first quadrant, increasing this way. So this is a graph. Then from here you will see this is our negative 2. This part is increasing. and this is 0. This part is increasing and this part is decreasing, so it is right. And if some of you didn't take advanced functions before calculus, please make sure review the factoring and also graphing of function part. Okay, so this is a chapter we are going to need how to graph a function from grade 12 advanced functions. Okay, so this is for this part. Finding increasing, decreasing intervals for a function by doing derivative and let derivative. First derivative equals 0, then solve for the zeros, draw the chart, put the zeros on this divider of the chart. Then 2 zeros, you have 3 intervals. 3 zeros, you have 4 intervals. So it's a zeros plus number of zeros plus 1 intervals divided out for the x-axis. So now we are going to see the next example, example 2. So it asks you sketch a graph of a function that is differentiable and satisfies the following conditions. So f prime x is greater than 0 when negative 1 to positive 3. So how to do this question? We want to draw that. You could draw the chart, okay? So negative 1 to positive 3. So if we draw the chart, x negative 1, positive 3, so it's positive, so it's increasing. And x less than negative 1 part is negative, it's decreasing. And x greater than 3, f is negative 2, okay? It's negative, so it's decreasing. So roughly we have the graph in this way. So we are going to draw the x-axis. And negative 1. So this is a y-axis, and negative 1 is where the graph changes the direction. So f at negative 1. From f prime, we don't know the value of f's function value, so they need to be given separately. F at negative 1 equals 0, so we have several points given. This is value of f at 3 is 4. So 1, 2, 3, 4. And f at 5 is 0. So these are the 3 given points. Then we are going to decide. So on the left side is negative, so the graph need to go down. Then from negative 1 to positive 3, the slope is positive, so it's up. Then from after positive 3 is going down again and past this point. So it's kind of some graph like this. So from this one, this is a slope negative is right, slope is positive is right, slope is negative is right, and 3 points given. So we have used all these given 6 conditions. And this is a function notation. What it means, this is your x value, and this is your y value, and it represents 1 point, negative 1, comma 0. This one represent a point. This is your x, this is your y, 3, comma 4. And this one is 5, comma 0. Okay, so they are the 3 given points. Function notation, one equation give you 2 informations, input and output. So this is for the example 2. From given information to do the graph, and we practice another one. So this one is given some information. This is f prime is given. So first the derivative is given, ask you to graph the function f. So from here we have several points given, negative 0.58 xy, this one x, y. So we have 3, 1 given. 3, 1. This is 1 point. Negative 0.5 is 8. Then from here on the left, the graph is positive, so it means it's go up. So from here to here is increasing. So left to right is increasing, the slope is positive. And from negative 0.5 to 3 is less than 0, so the slope is negative. It's going down from left to right. The slope is negative, it's going down, decreasing. And after that, from here is increasing, is positive again, so it's increasing. The slope is positive. So this is how we do the graph. We call this one is our function f at x. So we don't know where it is, just keeps going. So this is today's lesson. So today's lesson is f prime. If positive, then from left to right is up. If f prime is negative, then from left to right is down, so increasing. This one is decreasing. And how to find it? We need to find the derivative, then solve for zeros, and draw the chart. When we draw the chart is put the x value on the divider, okay? 2 f prime equals 0, then we have 3 intervals. If we have 3 f prime equals 0, then we have 1, 2, 3, 4 intervals. And here we are going to find y prime is positive and negative. Then based on the positive, negative, we can find the decreasing or increasing. So today's check your understanding is on Delta Math 4.1. Thanks for watching.